So thank you for the introduction. This is going to be a little different from the previous presentation for various reasons. One is that today I want to present these ideas to you and see what preliminary work we have been doing, but it's also an invitation for all the people here and in iARTA to participate in this effort. I think that there are many opportunities here that we can all explore together, and this is, as you will see, it's kind of a large size project. So one other reason that is different here, I'm starting from a different point of, perspective. I'm starting from something that is actually the result of many years of scientific research on materials. And as you see from the logo of this project, MaterialsSoundMusic, there are three different levels that I want to talk about. One is the material level, one is the sound that we can associate with these materials, and then there is the music that we can make out of it. So in a way, everything started with an initiative of the White House that is called the Materials Genome Initiative. That started in 2011, but actually the scientific work behind it started well before then. And the idea is to try to develop techniques to deploy materials from the research development to the application in a much faster time. And this project, this initiative, is focused on, from my point of view of our research, is on two important parts, and that they are the ones in the top and in the right bottom is the computational tools and the digital data. And you understand here that we will be talking from the perspective of data as large amount of data, not just the single input from a source, but here we are talking about a large effort that involves the development, in particular, of large databases of materials properties. And here is where we come in. I'm part of a large research effort that develops databases of materials property. When I talk about materials, I talk real materials, the metals that we use to make the cases, the elements that we use inside the computers to make the microchips, or any kind of material that you can think of is actually collected in these databases. The databases are large. Our database is more than 600,000 entries, and we are adding entries continuously, and is accessible. It's public, and is accessible through an interface that maybe you can lower the lights here a little bit. That allows you basically to choose which element of the periodic table you want your material to be made of. You click on them, and you get something like this. There is an entry in the database that tells you what is the structure of these materials. Those are the little atoms that make up the material itself. And they give you information about some of the properties of the materials that, at this point, let's keep it, let's take this as kind of a visualization of a scientific set of numbers. This is an important result here, because this is what I will be using as a prototype for this proof of concept of making sounds and music out of this data. And for a musician, this looks like a very polyphonic structure. You have a lot of lines that you can immediately associate with melodic lines. Although these are properties that determine what a materials can be used for, and so they have a very important role in the development of applications. Now, why I want to do this? We have developed over millennia a way of interpreting the natural world, and in particular, for instance, the sky, the universe, that is very much linked to a musical perception. The planets that are at orbits that are like fifths or minor thirds or fourths, and so we are used to think about an association between art, music, numbers and the world, macroscopic world, that is very clear to us. I mean, we are very familiar to these kind of things. We go to planetaria, we look at the stars, we look at the galaxies, and it's all comes together. But if I ask you, what does it mean to be inside of a piece of material, you probably don't know what I'm talking about. And so one of the goals of this project is also to kind of develop this kind of perception of materials that we don't have. And there are no examples that I can think of where this kind of approach has been taken. So what do I want to do with this? What I want to do is, my vision is to have a large-scale collaboration where this data can be used and remixed for exploitment in, expressive media, being video, music, sculpture, installations, whatever. And I actually have three avenues that I think we could take in doing so. One is to use kind of the virtual reality ideas that we've been hearing about to develop a way for artists and the people to actually experience this kind of data and behavioral materials in a way that is direct and sensory. We can think about, and I'll show you some examples of using this data to make large-scale installations that can be used also as a didactical tool, but also as performance space, where you can interact with all this kind of complex environment through music, sound, video, and yourself, your body inside of these objects. And on the third level, and this is what I would say is the musical level, we can use this data to actually make music, and I have some ideas on that I want to share with you. So the first layer of this problem is in the materials, the data that we have to use and manipulate in order to make them suitable for an artistic reinterpretation. As I said, these are big chunks of data. We are not talking about small numbers, we are talking about huge numbers. And so we have to develop a technology or a technique that allows us to do these operations in a way that in computational material science we call high throughput. So we want to do this a lot for a lot in many cases. This database that we are developing has a structure that is suitable for this kind of things. And I don't want to get into these details at all, but basically we generate data that are organized hierarchically inside the database that can be searched with a program that looks for the data that you need. And then you need to do something with this. And in particular, what we could do and what we have done, I mean, there is a prototype that I've developed that does exactly this. We can write programs and simple Python scripts that, I mean, simple, not very simple, but I mean, Python scripts that go into the structure of the database, fish for the data that I want to transform or remix, and then produces other text files that then I can use for other things. And in particular, I can transform this into MIDI data, frequencies in whatever temperament system that I want. I can use this as raw frequencies with microtonal. I can transform this in pitch sets and use them inside a composition. So basically, I produce files for further manipulation. There is an aspect of this that is also scientific because you can say this is a sonification project in a way, at least at the bottom. It starts as a sonification project. And when you sonify your data, you do it because you want to be able to explore the data space with things that are, I mean, with senses that are not just looking at the numbers. I want to be able to give signature, the gist of the data, out of a sound or out of an image. Now, let's give you a few examples. This is a typical result, like the one I showed you from the database. This is the information that is here, tells you something about the behavior of the electrons in silicon. Silicon is the material that is makes 90% of our computers. Well, I can transform this very easily into MIDI, and I can actually play it. If this one, why is not working? Hello? Is there any? Oh, this one. I need this. This one, this is just trivial mapping of numbers into MIDI numbers and then fed into whatever synthesizer that you have on Logic or Live or whatever you want. Clearly, this one could be a good way of giving the gist of the data, but artistically it's not really satisfying. It's like, whatever. So we can do something better with this. And to do something better with this, I have developed, or I started to develop, this is a work in progress, various patches, both with Super Collider and Max, that take this data and make something that is more artistically pleasing in terms of the sound design or in terms of the structure of the polyphonic structure of the data and so on. Now let's go into this. What can we do out of this now that we have a way of making sound out of this materials data? And so let's go into the first idea that I have, one that is actually has a direct implication in terms of the popularization of the science behind this, not just the artistification of the data. It is the creation of this virtual 3D environment that can be thought of like a video experience, like an IMAX projection, or as you will see, as a virtual reality environment. So let me show you a trailer for this particular idea that I have developed. This is very rough, but I hope it will give you a little bit of the sense. So this is kind of, imagine this, you scale it up to a longer time, more, elaboration. You can add a commentary, you can talk about these things because you can explain where are you in that moment that you are seeing these images. So this is this first concept. The second concept is the one of developing a virtual 3D environment that I call the virtual crystal with an X. And I have no idea how to do it, but Steven showed us that there are ways that one could do this. And so we have to talk to him, I guess, to get some ideas on how to exploit this technology that is already available to make something that you wear your goggles and you decide, okay, if I take this element here and this element there and put them together, what do I get? And how do I find myself inside of this kind of crystal environment? The second class, say, of things that I would really like to develop is instead places where you are actually working inside physically a structure that is your crystal. And it's what I call the crystal galleries. And this is kind of a concept idea that I developed in which you actually build an installation where you can walk in, and while you walk in, you are, you hear sounds, you can see projections, and it gives this kind of multisensory ways of exploring something that is very physical. I mean, this is what is inside of your computer. This is silicon. I mean, you will never see like that, but that's exactly what that is. And so you can think about things like you put speakers in all the atoms, and then you have sensors. You do projection of different. I mean, you can, for instance, transform data in video and project the video on these installations. So, of course, this is very ambitious because something like this is probably very expensive. But I think that there are ways, and I'll briefly touch on this, that these things can be made happen. Now, the third layer of complication of this project is the one that has to do with the use of this data as compositional elements in music. And this is, if you want, is the more intimate part of it, because it's left to the composer to decide how you want to do this and what to use and what not to use. Well, I mean, as an example, you can use the data as starting compositional elements, and there is this piece for which I don't have a recording that I started to work on, and is almost finished, where this is a piece for fluid and electronics, and the electronics is a direct input from the structural data of the database, while the fluid part takes the data transformed into pitch set classes and uses that in a compositional way. I mean, to give you, let's see if I. Okay, this is a max patch that reads the data of the database. In this case, it reads 8 different parts of data, and produces a MIDI output that can be that I routed through live, and I make sounds that are different from these ones. This is just the typical MIDI realization, but it adds a lot of volume and information to the sound. And part of this, okay, where is it? No. Hello? Here. Yes. So part of this, I'm proposing here this idea of having a composition prize on this data. This data will be made public very soon, because we are actually building a mirror of the database here at UNT, so that everybody will be able to access this musical data, the data that have been transformed already into musical elements, and then make a composition prize or a festival, and see what we can do with this as a community. I think this is something that has a lot of it can impact outside of our environment, the general public in a way that has never been impacted before for this kind of concepts. Now, what are the tasks? There are many tasks that we have to look at in this. Some of these tasks have been already tackled, or at least we started to tackle them, but there is still a lot of work to do. I mean, basically, the tasks are the things that I showed you. Some of this already exists. Some of this are just in my mind or in these pictures. And since I would like this to be a collaboration of all of us together, I actually put a slide on funds and where do we find the money for this. I'm already starting to look for funding for this project through my channels, the channels of the materials community. And I applied for a grant of the Material Science Foundation. We'll see what happens. But I'm sure that we should look for the involvement of other partners, like museums or community involvement, because I think we have a chance here to change the perception through art and the collaboration between and the synergy between art and science to change the perception of people about not just music, but about the world of materials. Thank you very much.